you see? And divide it by the number of molecules. So you have the average speed. Okay. The root mean square speed you can calculate differently. So you have to square each speed. You sum it up. You divide for the number of molecules, and then you take the root square to have the final result. And for the most probable speed, actually the most probable speed, this is the speed that most of your particles will have. And you just look at the table. So you see that there are 8 particles having the same speed at 4 centimeters per second. So the most probable speed should be 4 centimeters per second. In the slide that I gave you, we only use it when we know what the gas is and what the temperature of the gas is. Then we will use the formula. Okay, because here we do not know the temperature of the gas. How can you use that kind of formula? Is it okay for you? This is the number 16. Good. Number 20. No one? Đó, các bạn chú ý nha, cái công thức mà chúng ta nhắc tới ở trong slide đó, thì các bạn phải biết được khí ga đó là khí ga nào và nó ở nhiệt độ bao nhiêu, thì các bạn mới dùng các cái công thức đó. Còn đây là cái bài 16 này, ta chỉ nói tới cái ý nghĩa của 3 cái này. So who can do number 20? No one? Number 20, we have a closed cycle on a PV diagram. And here what we have is a diatomic gas. So Vương Đăng Thái, what is the degree of freedom of a diatomic gas?
Hello.
Yeah, I hear. Okay. What is the degree of freedom of a diatomic gas? Come on. But you know, you say no. If you don't know, you say no. So I ask others. Các bạn đây rất buồn cười nhé. Tôi hỏi, các bạn biết thì các bạn trả lời, các bạn không biết các bạn không trả lời. Cứ thấy các bạn đấy thôi. Còn bây giờ mới đi tìm tài liệu thì không trả lời kịp đâu.
No.
Phải đọc lại slide.
Yeah.
Nguyễn Nhật Anh này, do you know?
Dạ. Không, con vừa mất tập trung rồi.
Stay focused. What is the degree? What is the degree of freedom of a diatomic gas? Do you understand the question?
Yes. But
If you read my slide, you should answer in 1 second.
I'm sorry, but I didn't read the slide again. Sorry.
Chết thật. Này thì học hành gì? Diệu Anh, Đỗ Diệu Anh.
Sorry, I don't know.
Chết, ngồi đây không ai biết gì à? Nhất. You learn it last time, yesterday.
But I did not listen to the question, like carefully. So I did. Can you repeat the question?
Thôi thì các bạn cứ ngồi ở trên màn hình, xem các bạn không nghe tôi nói thì các bạn ngồi làm gì?
Em có nghe nhưng mà đoạn đấy. Thầy hỏi về
Đấy.
đai không đa của Diatomic ạ?
Các bạn thấy một câu hỏi mà tôi nhắc lại lần này lần thứ 4. Thì có chết à? What is the degree of freedom of a diatomic gas?
I'm sorry, I don't know.
Ôi trời ơi, thế thì ngồi đây làm gì? Tất cả các thanh niên. Please, I provide you already the lecture slide. Before going to the tutorial part, you should reread my slides. When we talk about the degree of freedom of a molecule, we are talking about the number of ways this molecule can store energy for a monatomic gas. So I mean the gas having only one atom, right, in the molecule. For example, helium, for example, argon. They will have 3 degrees of freedom. What are they? Đặng Văn Tuấn.
I don't know.
No, you do not stay focused. What I just explained, can you repeat?
It's just about degree of freedom of diatomic gas, but I
Đấy, thấy chưa?
yeah, actually.
Không tập trung gì đâu. Không tập trung một tí gì cả. Chỉ thấy nhìn cái gì cười cười gì là, hay là chat hay làm gì cười cười. Vừa mới nhắc làm gì có tới diatomic gas nữa. Tới lúc giải thích cũng không nghe. Tất cả những cái thanh niên này sợ thật đấy. Nguyễn Xuân Anh.
Oh, I don't know.
What I just explained, can you repeat it?
I do not focus. Sorry.
Okay, you have the choice. You don't want to stay focused on here, it's fine. I will not force you. For example, here I have Nguyễn Vũ Bách. Also, the camera is not on. Vũ Xuân Bảng, also camera not on. Who else? You can do the exercise by yourself. Okay, I will not ask you the question. because I know that even I ask, you will not be able to answer because you did not reread my slide, you do nothing. Then I also do not force you. Yeah, you can go out if you like. I do not force you to learn it. Here I explain for people who want to stay here and who really want to study. Okay, the degree of freedom for a monatomic gas is 3. For a diatomic gas is 5. Please reread my slide. And the change in internal energy can be written in this form. So here is the internal energy equal N F over 2 RT, this form, okay? And since we have a PV diagram, what we know is the pressure and the volume. Then we reread this expression. Now we can calculate the change in internal energy. This one. For the work done during the process and the heat, because what we need is to find the heat of the path AC. For example, we need to determine the work first. The work is actually the area under the curve. I told you so many times, this area. Then you should be able to calculate it here. Then you use the first law of thermodynamics, and you have the heat done by the process AC. For the process BC, you also do the same. You calculate the work of the process ABC. Okay, also the area under the curve. Here BC does no work, only AC will give you the work. So the work of ABC is only the work of AC. And then you should be able to find the heat. Good. So this is for question 20. Now for question 21, we have 3 gases and we mix it together. We know the number of mole of each gas. We know the molar specific heat at constant volume of each gas. What we want to know is the molar specific heat of our mixture. Okay. So for any gas, you can write the change in internal energy as this one, and CV delta T. So we apply for the gas number 1, number 2, number 3. And the change in the internal energy of the mixture is actually the sum of the change in the internal energy of each gas. Do you agree with me? Then the change in internal energy of the mixture can be written in this form. So the sum of each change in internal energy. But if we consider the mixture as a gas, a new gas, we can also write the change in internal energy of the mixture as this one. And here CV is the molar specific heat at constant volume of the mixture. And finally, we should have this one, okay, equal this one, right? And from this and this, you should be able to find the CV, the final expression of CV. And after that, we should be able to calculate the CV. Good. This is number 21. Yeah, thank you, Vinh. Now, I invite you first to rewrite carefully my slides. Secondly, you can stay focused. You do the number 24 to 28. Okay. If you want, you can take a break of 10 minutes and then you take another 10 minutes. Then after that, I will correct the number 24, 25, and also 26. Bảng ơi, please, you can capture the screen and then you send the file to me. Here you send me the doc file, the Google Doc, but I cannot get access also, and it will be more complicated for me. Nhé, và em gửi tôi cái link này mà còn không cho tôi access thì để làm gì? Chụp lại màn hình gửi luôn qua đây cho nó nhanh. Okay, so 10 minutes break, or you can take time to reread my slide and you do number 24, 25, and 26. Number 28 is very important. Number 28 was part of the exam last year. And this is also the level of the exam, the final exam. This is a combination of the first law and the kinetic theory of gases, which is very interesting. So what I want you to stay focused is the number 28. So we should save time to do number 28. Also, when I come back, please turn on your camera. Otherwise, if I do not see you here, I will delete the attendance checking that I already done. This is for after the break, okay? Trang ơi, tôi vừa giải thích đó. Đề ở cái file cũ là nó bị sai. Và tôi đã upload lại một bản mới và gamma nó là 4/3. Chú ý nghe bằng tiếng Anh. Ok. In the old version, there was a mistake. For the question 25, the gamma was written as 3/4, but actually it is 4/3. What is gamma? Trang, Nguyễn Quỳnh Trang, what is gamma?
Có hai bạn Quỳnh Trang ạ.
092 đây này. What is gamma? Quỳnh Trang. Microphone đâu? So what is gamma then? Bạn Quỳnh Trang 091 xem nào. Trả lời hộ bạn Quỳnh Trang 092 xem nào. Học phải chọn chỗ nào yên tĩnh mà học chứ. Không thì sao học được. Rồi, bạn Nguyễn Quỳnh Trang 091 nào.
Dạ, chắc là hằng số gì đấy ạ.
Okay, we have gamma. It's already written in my slide also. Reread my slide. But gamma is the ratio between CP and CV. CP is the molar specific heat at constant pressure, and CV at the molar specific heat at constant volume. We call gamma the ratio between them. Okay? So we start the correction. Who can do the number 28? Who has finished? So I start from 26. Here the 26 is very quick. What we want to know is the change in internal energy, right? Or the path 2. But actually the path 2 or path 1 is similar. They have the same change in internal energy because they have the same initial and final states. Okay. But the characteristics that we know belong to the path 1. What do we have for path 1? We have an isothermal process followed by an adiabatic process followed by another isothermal and another adiabatic process. Good. Firstly, what we know is that the change in internal energy of path 2 equals that of path 1. Okay. And then what do we have for isothermal processes? What do we have isothermal processes? We have the change in internal energy equals 0 because we can measure the change in internal energy using NCV delta T. And since delta T equals 0 and delta E also is 0, then the change in internal energy of the whole path is only the sum of the change in internal energy of the two adiabatic processes. Okay, the two adiabatic processes. Is it okay until here? And for adiabatic processes, what we know is that the heat equals 0 already. Then delta E should be equal to minus W according to the first law. So the change in internal energy equal minus the work done by the gas. Okay, then we should have the change in internal energy of the adiabatic expansion. So this is an expansion. And this is an adiabatic compression. Finally, we should be able to have the final result. So this is the answer for question 26. Question 27, if you remember the exercise that we did together during the lecture, we apply the same thing. We start from the constant, right? PV power gamma is a constant. PV power gamma is a constant. PV power gamma, I'm looking for the gamma here. Is a constant. Then what we have at any moment, we can have PV power gamma equal pi vi power gamma, because pi vi is what we know, so we relate what we don't know with what we know. In this way, you can rewrite the expression of P, right? So P will be pi vi power gamma divided by V. And then you replace this one into the expression to calculate the work. Right? You know that the work equal integral of PdV, then you should be able to have this expression. If you still do not understand, I recommend you to reopen the slide, the lecture slide. Then you should be able to have this. Good. This is number 27. Let me check if someone has the solution for number 28. Quỳnh Trang and Quang Vinh, Quỳnh Trang and Trung Anh. Next time when you send the file to me, I ask you to rename the file already. Good, Quỳnh Trang. Yeah, and Quỳnh Trang also has the solution for 28. Very nice handwriting. Okay, good. Let me correct together. Thank you very much, Quỳnh Trang. Nice. Now, here we have once again a closed diagram, a closed cycle, I mean. And from 1 to 2, we have a constant volume process. From 2 to 3, we have an adiabatic process. 3 to 1, we have another adiabatic process. Good. What we use is a monatomic gas. So for a monatomic gas, we have a CV. Monatomic gas, we have CV equal this value. Cp is this value, okay? Now, we want to know the heat of the process 1 to 2. Because this is a constant volume process, then the heat equal NCV delta T. This can be applied for a volume, constant volume process. Good. And we know that for a constant volume process, the work done is 0. The work is 0. And then we use the first law. We should be able to have the change in internal energy. So this is B and C also. The process 2 to 3, we have an adiabatic process, then the heat is 0. Good. And the change in the internal energy is NCV delta T. So at any moment you can write it. This is applied for all processes. Biến thiên nội năng bao giờ cũng có thể được tính bằng công thức này nha. Chỉ có ví dụ như là trong quá trình đẳng tích chẳng hạn thì thằng Q này nó cũng bằng thằng delta E, cho nên là nó đều được viết là NCV delta T. So then, once again, according to the first law, we can calculate the work. For the process 3 to 1, what do we have? 3 to 1, this is a constant pressure, right? Then for a constant pressure process, we can write the heat equal NCP delta T. This time we use CP. Then we should be able to have the final result. The change in the internal energy, once again, equal to NCV delta T. And according to the first law, we can calculate the work also. For the entire process, then the heat is actually the sum of that of each process. Then for the entire process, the net heat will be the sum of each heat. The change in internal energy also, and it should equal to 0. So for this, you can redo the calculation to verify that we really have 0 at the end. It should be 0. The work also, the sum of the third at any state. Then we use the ideal gas law, right? For example, the volume 1, we can calculate. For the pressure 2, we can calculate. For the volume 3 also, we can calculate it all using the ideal gas law. Is it okay? So this is the question 28, and I hope that you can do it by yourself, because this is the level of the final exam. Good. Do you have any questions? No? Okay, if you have no questions, then I thank you. We can stop here. I will take a little bit more time to give you bonus for people who already sent me the file. And also, please remember that you send me your notebook, a copy of the notebook of today via my email, like I said at the beginning, to give you the 4-point bonus.
Do I have to include the class name and the student code?
Yeah, you can write me because you send me an email, right? You do not add to your file, but you add to your email.
Yeah, I know, but my email has my name and the student code. Do I have to write?
No, I do not check your email address. I check the content of your email. So you still have to add it.
Okay.
And please send me today, okay? Not tomorrow. Anh. Quang Vinh. Yeah, you can stop now if you have finished. So thank you so much for